Hello and welcome to our lesson on the exact values of sine, cosine, and tangent for specific angles. Today, we will build on our understanding of right-angled triangles by introducing some fundamental trigonometric values that are essential for solving geometric problems involving these triangles. In this lesson, our main objective is to learn and remember the exact values of sine, cosine, and tangent for the angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. In our previous lessons, we've established a strong foundation by exploring right-angled triangles and their properties. We have also learned Pythagoras' theorem and used this to determine the relationship between the side lengths of a right-angled triangle. With our foundation in right-angled triangles and Pythagoras' theorem, we can now dive into the exact trigonometric values for specific angles. We'll begin by focusing on some specific angles that frequently appear in trigonometry problems: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. To help us remember the sine, cosine, and tangent values for these angles, we can use two special triangles and a bit of memorization. Special triangle 1 is the isosceles right-angled triangle. This is shown on the right. Both the sides adjacent to the right angle are of length 1. The hypotenuse will have a length of square root 2. We can work this out through Pythagoras' theorem. Let's remind ourselves of our trigonometric ratios. We know that sine equals opposite over hypotenuse, so we find that sine of 45 equals 1 over root 2, which we can simplify to root 2 over 2 by multiplying the top and bottom of this fraction by root 2. This is known as rationalizing the denominator, and if you're unsure about this, take a look at the numbers module in this course. We know that cosine equals adjacent over hypotenuse, so we find that cosine of 45 also equals 1 over root 2, which can again be written as root 2 over 2 by rationalizing the denominator. Finally, we know that tan equals opposite over adjacent, so we find that tan of 45 equals 1 over 1, which we can just simplify to 1. Let's turn to special triangle 2, the 30-degree, 60-degree right-angled triangle. Consider an equilateral triangle with each side of length 2. By splitting it down the middle, we get two 30-degree, 60-degree right-angled triangles. Looking at the triangle created on the right, it has a hypotenuse of 2, a base of 1 and a height of root 3, which we can calculate using Pythagoras' theorem. Using a similar method to our previous triangle, we can find the exact values of sine, cos, and tan for 30 degrees and 60 degrees. First, let's focus on our 30-degree angle in the triangle. We know that sine is opposite over hypotenuse, so we find that sine of 30 degrees is 1/2. We know that cos is adjacent over hypotenuse, so we find that cos of 30 degrees is root 3 over 2. Finally, we know that tan is opposite over adjacent, so tan of 30 degrees equals 1 over root 3, which can be written as root 3 over 3. Now let's look at the 60-degree angle in the triangle. Sine is opposite over hypotenuse, so we find that sine of 60 degrees equals root 3 over 2. Cos is adjacent over hypotenuse, so we find that cos of 60 degrees equals 1/2. Finally, tan is opposite over adjacent, so we find that tan of 60 degrees is root 3 over 1, which we can just write as root 3. So that's how we use this triangle to help us remember the exact values of sine, cos, and tan for 30 degrees and 60 degrees. In addition to the special values we've covered, there are some additional ones which do not correspond to any triangles. These are as follows: sine 0 degrees equals 0, cos 0 degrees equals 1, tan 0 degrees equals 0. For 90 degrees, we have sine 90 degrees equals 1, cos 90 degrees equals 0, tan 90 degrees is undefined. There isn't a triangle that we can remember to help us with these ones, so they just have to be memorized. Overall, this gives us the following table of the exact values of sine, cosine, and tan. Remember, all of these values in the middle of the table can be learned by memorizing the two triangles. If you can draw both of these triangles, then you can quickly calculate the exact values of sine, cos, and tan for these degree values. This is often easier than just memorizing all of these results and can reduce the chances of making an error. By mastering how to find these exact values and applying the appropriate trigonometric functions, we can efficiently solve various problems involving right-angled triangles. In today's lesson, we explored the exact values of the sine, cosine, and tangent functions for specific angles. We used two key triangles, the 45-degree, 45-degree, 90-degree isosceles right-angled triangle, and the 30-degree, 60-degree, 90-degree triangle derived from an equilateral triangle to derive these values. Knowing these exact values will allow you to identify common features in geometric problems and solve them with ease.